Good morning. I'm George Solomon from Communication and Power Industries. Today we're going to talk about interpulse noise in radar amplifiers. What is interpulse noise in a radar amplifier? We get this question a lot because it's not one of the common measurements done for radar amplifiers. And why is it important to the radar? The interpulse noise is the amplified noise between the end of the transmitted pulse and the beginning of the next pulse. During this time, the radar is looking for targets within that range. So ideally, the radar amplifier would have no interpulse noise with a noise level of KTB of minus 174 dBm per hertz. So this represents a noise measurement problem when you're trying to measure the noise with standard test equipment. The typical noise floor of a spectrum analyzer is 151 dBm per hertz, and the signal we're trying to measure is at 170 dBm per hertz. So there's 20 dB difference between the noise floor of the analyzer and the measurement. So to improve on that, what we do is to enable the analyzer to measure the 170 dBm per hertz. We amplify the noise with a LNA and then extract the noise and the gain and noise figure back from the measurement. The interpulse noise is the measurement between the end of the transmit pulse and the beginning of the next pulse. So the test set is very simplistic. We terminate the RF input of the SSPA. The SSPA is then fed into an LNA and then into the spectrum analyzer. We do not have an RF pulse, but we use the gate signal to turn on and off the power to the SSPA. The interpulse noise, we can see from this measurement, the typical noise floor is measuring at about 132 dBm per hertz. We amplify the signal during the pulse, and then at the end of the pulse, we get back down to the noise floor of 132. And what we're looking for is the time associated from the end of the pulse to when we get back down to thermal noise. The gain of the LNA that we use is 39 dB with a 2 dB noise figure. So that relates to a noise floor of the measurement of 133 dBm per hertz to enable the spectrum analyzer to measure this noise in standard test equipment. The noise figure of the LNA degrades the measurement by about 2 dB, but enables the analyzer to take that measurement. I hope this information was helpful. If you have any questions, come visit our booth or visit our website at cpii.com. Thank you very much.